Here's your Chapter 11 review for everything that's going to be on the Chapter 11 test. Our first section was 11.1, and this was our polynomial terminology. So the first thing we're going to talk about is standard form. Standard form for any polynomial is making sure that it's in order with descending degrees. So all of our answers should be in standard form. The next thing we're going to talk about is naming. We named polynomials by the number of terms. So if we only had one term in our polynomial, we called this a monomial. If we had two terms in our polynomial, we called this a binomial. If we had three terms, we called that a trinomial. And if we had four or more terms, we called this a polynomial. The next thing we did was leading coefficients. The leading coefficients for a polynomial is the first term. It's the first coefficient when it's written in standard form. So the first thing we have to make sure it's in is standard form. And then we pick off the number, the coefficients on the first term. Next we have a constant. A constant is a number with no variables. So if we just had like 5 or plus 8, that was our constant number. The next we have is the degree of a polynomial. Now when we determine the degree of a polynomial, it is always the highest degree. After you figure out the degree of all the terms, when you get them in standard form, you pick off the highest degree, and this will tell you the degree of the polynomial. Once we decided the degree of the polynomial, we classified these. If the highest degree of the polynomial was 0, this was labeled the classification a constant. If the highest degree was 1, we classified this as linear. If the highest degree on the polynomial is 2, this was our quadratic. If the highest degree on the polynomial is 3, it was called a cubic. And if the highest degree on the polynomial is 4, we called this a quartic. And after that, we just called it a 5th degree polynomial, and so on and so forth. If you need refreshing on all these polynomial terminology, refer back to 11.1. In 11.2, we added and subtracted polynomials. This is when we combined like terms. So if I gave you the polynomials 3x squared minus 3x minus 5, adding to 2x squared plus 5x plus 3, we group together our common ones. So I'm going to put my arrows for my x squareds, my x's, and my constant terms. This is only when we have an addition sign in between. Now we can group those together and add them. So I have 3x squared and 2x squared, which gives me a total of 5x squareds, negative 3x and positive 5x, which adds together to positive 2x, and negative 5 with positive 3, which adds together to negative 2. Notice my answer is always in standard form. This degree was highest was 2, the next degree was 1, and the last degree was 0. There are 3 terms in this one, which makes this a trinomial. The leading coefficient of this one is 5. The constant in this one is negative 2. The degree of the polynomial is the highest degree. The highest degree in this one is 2, which classifies as a quadratic. All right, the next one we did was subtraction. If I subtracted 2x cubed plus 8x squared plus x minus 5x squared minus 4x, I would first have to distribute my negative. So my negative distributes to both of these terms, and I'm going to rewrite my two polynomials. I have 2x cubed plus 8x squared plus x, changing the sign to a negative 5x squared and changing this sign to a positive 4x. Next, I have an addition problem, so I'm going to combine my like terms. This is my only cube term, but then I have an x squared, and an x matches with my x. So putting this in standard form for my final answer, 2x cubed, 8x squared and negative 5x squared gives me positive 3x squared. X and 4x gives me 5x. So this is my final answer in standard form. One more type of problem we did with addition and subtraction. If I had 2x squared plus 5 minus x squared minus 2 plus x cubed plus 10, I've got to distribute the negative, but only to this binomial. This is a plus sign in front of that one. So I'm going to first distribute the negative to this binomial, and I have 2x squared plus 5 minus x squared plus 2, and then these signs will not change, x cubed and positive 10. Last, I'm going to combine my like terms. So I have 2x squareds here, and I've got some constants here, and this x cubed is alone. So starting in standard form is my x cubed, then my x squareds. 2x squared minus 1x squared leaves me with a positive 1x squared. Positive 5, positive 2, and positive 10 leaves me with a positive 17. So that is my final answer in standard form. Okay, next in 11.3, we multiplied polynomials. We started with two binomials like x minus 2 times x minus 3. For this one, we distributed to all the terms. Notice there's no plus sign here. That's how I know this is multiplication, because these are butting up towards each other. So I'm going to multiply my x to both of those terms. X times x is x squared. X times negative 3 is negative 3x. And then I'm going to distribute the negative 2 out to both of those terms. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. My last step, I would combine my like terms to get x squared minus 5x plus 6. The next thing we did with multiplying, if I had here x plus 5 quantities squared, we could use the square of a binomial pattern, which the square of a binomial pattern here would be the first one squared. Then the middle term is the term is multiplied together with a 2, and the last term is the last term squared. If you forget the pattern, please remember that squared is x plus 5 times x plus 5. When I multiply these together, x times x gives me x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. Combining my like terms, this simplifies to x squared plus 10x plus 25. All right, and one last thing that we had done for multiplying, we had multiplied 2x minus 4, 4x plus 1 times 3x plus 3. When we multiply three binomials together, multiplication, we can multiply these two together first and then multiply it to the last term. Multiplying these together already simplified, I would get 8x squared minus 14x minus 4, and then I would drop down my 3x plus 3 and multiply that. And I would make sure I distributed out each of the terms from the trinomial to each of the terms in the binomial. My final answer for this one, if you want to work it out, please work it out, but the final answer for this one ends up being 24x cubed minus 18x squared minus 54x minus 12. The next one we did was applications of polynomials in 11.4. We did perimeter, where we added up all the sides for the shape by combining our like terms. Area for a rectangle is length times width. Area for a square is just your side squared. Area for a triangle is 1/2 base times height. Then we had volume for a prism and for a cube, length, width, and height. And last we did surface area. We did it for a prism, 2LW plus 2LWH plus 2LH. And we also did it for a cube. So don't forget that you need to know these formulas and you need to know how to use them. This will be on your review tomorrow for those practice problems. Then we moved on to factoring. 11.5 was our GCF, our greatest common factor. So here we have 36y minus 24. So between 36y and negative 24, they have a 12 in common. So I can factor out a 12, which would leave behind 3y minus 2. And this is fully factored, so all it had was a GCF. So practice with another one, a couple more variables. 6x cubed plus 12x squared minus 9x. So between 6, 12, and 9, they all have at least a 3 in common. And then between x cubed, x squared, and x, they do have an x in common. So this would leave behind 2x squared plus 4x minus 3. Now this may factor, but we're just worrying about factoring GCF, practicing that GCF with all these problems. The next one we have 4x squared y squared plus 12xy squared minus 4xy. So looking between the numbers first, 4, 12, and 4, they all have a 4 in common. Now looking at my variables, x squared, x, and x, they do have one x in common. And y squared, and y, they only have one y in common. So if I factor that out of my first term, the 4 would come out, 1x and 1y would come out, leaving behind 1x and 1y in the first term. 12, taking out 4, would leave a positive 3. Taking out the only x, and then it was leaving 1y behind. And the last term took out the 4, the x, and the y. But we still need a placeholder for 1, so I'm going to put minus 1 to make sure that multiplies back out. Okay, moving on to 11.6. This is when our A term equaled 1. This was making us happy because these were our easy problems when we did not have a term out front. So our first problem we have today is x squared plus 12x plus 32. Now this was the easy ones where we did not have to worry about this A term. We can go ahead and write out our factors. X times x would give us our x squared. And we can use our graphic organizer to find what multiplies to 32 but adds to positive 12. We use this to find our two terms of 8 and 4, and these were the terms for our positive 8 and positive 4. You can multiply these back to check. X times x is x squared. X times 4 is 4x, 8 times x is 8x, and 4 plus 8 gives us our 12x, and 8 times 4 is 32, so we know we have this factored out correctly. Practicing another one, if I had 2x squared minus 10x minus 48, noticing first a is not 1, but this is when we had a GCF. So 2, 10, and 48, we do have a GCF of 2, which would leave x squared minus 5x minus 24. And now we can factor this out. 2 x times x will give me my x squared. And then I can set up my graphic organizer with negative 24 and negative 5. The two factors that make this work are negative 8 and positive 3. So I put in here minus 8 and plus 3, and this would multiply back to the original if we checked that out. Flip it over to the back side. $11.7 is when we started to have a term out in front instead of 1. So the first section we did was when a was prime, and this is when we used our guess and check method. So for our first one here, 2x squared plus 7x plus 6, we listed off our possibilities. For 2, we have 2 times 1, and that is our only possibility. So we have 2x and x for our front term. But for 6, I have 1 times 6 and 2 times 3. You have to guess and check until you find them to equal that middle term. This ends up being positive 3 and positive 2. 2x times x is 2x squared. 2x times 2 is 4x. 3 times x is 3x, which 4 plus 3 will give me 7. And 3 times 2 is 6. Practicing with another one, 9x squared minus 24x plus 12. Still always checking for GCF first. In this case, between 9, 24, and 12, we have a 3, which leaves 3x squared minus 8x plus 4. Now I can factor this out. My possibilities for 3 are 3 and 1. So GCF comes first, then I have 3x and x. My possibilities for 4 were 1 times 4 and 2 times 2. This ends up being negative 2 and negative 2. 3x times x is 3x squared. 3x times negative 2 is negative 6. Negative 2x times x is negative 2, which gives me my negative 8. Negative 2 times negative 2 is positive 4. My next one was when a was equal to anything. So this time it does not have to be a prime number. For practice, we have 4x squared minus 4x minus 15. Now we have multiple possibilities for our a term, 1 times 4 and 2 times 2. For 15, I have 1 times 15 and 3 times 5. So we just have more opportunities for guessing and checking. This ends up simplifying to with the factors of 2x plus 3 times 2x minus 5. Another one, if you want to pause the video for practice, 6x squared plus 41x plus 63. List your possibilities out for each of those terms. And 63. And guess and check until you find the correct factors. This one factors out to 2x plus 9 times 3x plus 7. Our third video for 11.7 was our special cases. The first one we practiced was difference of two squares. Now don't forget this word difference. There does have to be a subtraction sign in order to factor these out. So for example, if I had the problem x squared minus 25, both of these are perfect squares. Square for x would be x times x, and 25 would be 5 times 5. This factors out then to the conjugates x plus 5 times x minus 5. Now, we also had problems that we had 16x squared minus 4 when we had a GCF first. So a GCF of 16 and 4 is 4, which would leave 4x squared minus 1. And then I have the difference of two squares. So putting 4 on the outside, 4x squared is 2x, and 1 will be 1 times 1. So I have 2x plus 1 and 2x minus 1. The second one that we did was a perfect square trinomial. These came a little bit easier for factoring because we had factored these already. So I'm going to actually do one of these with our two variables to remind ourselves how to do the two variables as well. So if I had x squared minus 14xy plus 49y squared, our pattern for this, noticing our x squared there, will factor to x and x, and then finding what multiplies to 49 but adds to negative 14. In this case would be negative 7 and negative 7. And then my y squared term just puts a y on the second part. So x times x is x squared. Negative 7xy and negative 7xy get me negative 14xy. And negative 7y times negative 7y is positive 49y squared. We would rewrite this answer, since it's the same exact binomial, as x minus 7y squared. 11.8, we did factor by grouping. So for example, this is when we had our four terms. 4x cubed minus 12x squared minus 5x plus 15. Here we look for a GCF in the beginning, which this does not have a GCF between all four terms. So then I split the problem in half. 4x cubed and negative 12x squared, I have 4 in common with the numbers and x squared in common for the variables. So that would leave on my first term x and my second term minus 3. Then I look at these two terms, what I can see it has a 5 in common, but the signs are going to be opposite right now, so I've got to factor out a negative 5. So this will leave on the first term a positive x, and the second term a negative 3. Now we know we're doing factor by grouping correctly if these have matched up. So my final answer will be factoring out the x minus 3. And then the leftover after I factor it out would be 4x squared for the first term and a negative 5 from the second term. And this is fully factored. Always check for GCF though in the beginning and check it in the end in case you missed it. 11.8, we also did factor by grouping with our trinomials. Sometimes this can make the problem messier, but sometimes it's just a good tool to have in our toolbox. So I'm going to give you the problem 10x squared minus 91x plus 9. Now in order to factor by grouping, we need to make this into 4 terms. We find our 2 terms in the middle by first multiplying my a term and my c term together. 10x squared times 9 is positive 90x squared. This will go in our graphic organizer up top, and my b term still goes in the bottom, negative 90x. The two terms that make this work are negative 90x. Oops, this one's negative 91. My apologies. And negative 1x. These add to negative 91x, and they multiply to a positive 90x squared. So then I rewrite my trinomial as a 4-term polynomial, 10x squared minus 90x minus x plus 9. All I did was replace these two terms in the center to rewrite that middle term. Now that I have 4 terms, we factor by grouping. Between 10x squared and negative 90x, we have 10x in common, leaving behind x minus 9. This one is already similar with the numbers, but the signs are opposites. So I do need a negative 1, leaving behind x minus 9. Once again, we want these to match up, and that will be the first part I factor out. And the second part is what's left over, 10x and a negative 1. The last thing I want you all to look through is our applications for factoring. If I give you the area and I said to find the possible expressions for length and width, we know the area is length times width. So if I give you the area, all you have to do for this is factor, and the two factors that you find are the possible length and width. Same for volume. First thing you do is factor a GCF, then factor the polynomials to find the possible expressions. So this one was one about volume. It had a GCF of 3x, and then I factored it to 3x plus 2 and x minus 5. So that's all you have to do for your applications for factoring. All right, be ready to review.